Hello, we are from Group 9. So we are going to present equation of application of ODE. This is our group members. We have 4 in total. So this is the question. Let me read the question first. A 1,000-gallon holding tank that catches runoff from some chemical process initially has 800 gallons of water with 2 ounces of pollution dissolved in it. The 800 gallons of water is included with 2 ounces of pollution. It is the initial condition, which is after function, which is t0. This that is the condition, and then the polluted water flows into the tank at a rate of 3 gallons per hour and contains 5 ounces per gallon of pollution in it. 5 ounces per gallon meaning that each gallon that flows contains 5 ounces of pollutions. So if 3 gallons flows in, and that means that about 15 ounces of pollutions are included in the fat as well. A well-mixed solution leaves the tank at 3 gallons per hour as well. When the solution is fed into the tank, into the mixer, it will mix and it will leave the tank with the same flow rate as it is fed into the tank. And then when the amount of pollution in the holding tank reaches 500 ounces, the inflow of the polluted water is cut off. It means that if the 5 ounces per gallon of pollution reach until 500 ounces, the flow rate, this one, the polluted water flow rate, this one will be cut off, and a new stream will be coming in, which is the fresh water, but it will into the tank with a decreased rate of 2 gallons per hour, while the outflow is increased to 4 gallons per hour. This means that the outlet is 2 gallons per hour higher than the inlet. So we want to determine the amount of pollution in the tank at any time. So this is the BFD, the block diagram that I have drawn. So for the first situation, 3 gallons per hour that contains 5 ounces per gallon enters the tank, and about 3 gallons per hour also will leave the tank. And then after it reaches 5 ounce pollutions, this is the maximum, and then this stream will be cut off and will be replaced with a new stream, which is 2 gallons per hour of fresh water. And then the outlet will be 4 gallons per hour of the mixed fresh water and the polluted water.
So now we are going to proceed to our solution part. As you can see here, Q1 you will have Q1 rate function and Q2 rate function. Q1 rate function and Q2 rate function are for two cases of the rate of pollution of the water. Q1 rate function is for the polluted water before the 500 ounces, before it reaches 500 ounces of polluted water. Q2 rate function is for after it reaches the 500 ounces of polluted water. As for Q1 function, you can see there are two separate components with left and right. The left hand side is called the inlet, the right hand side is called the outlet. As for the inlet part, 3 has a unit of gallon per hour, 5 have a unit of ounces per gallon, and if you concluded it, if you multiply both of them, you will get ounces per hour. So minus by the outlet, 3 has a unit of gallon per hour, and Q1 function has the unit of ounces, and 800 has a unit of gallon. So concluded, this whole component will have the unit of ounces per hour. Q1 function divided by 800 because we use Q1 function divided by 800 because 800 is the uh, initial volume of water, and the Q1 Q1 function keep on varies as time passes by. The volume water Q1 keep on varies as time passes by. As for Q2, it's the same thing. As for the inlet, you can see that the 2 multiplied by 0 as stated as in the question. As for the outlet, 4 times the Q function of Q2 function divided by 800 minus 2 times T minus Tm. 2 times T, we use 2 times T minus Tm because um, there is a decreasing rate of 2 gallon while the fresh water enter the tank. So it will come 2 gallon of water will come out each second from the tank. So we have to minus this one, minus use T, use the time, minus with the Tm is the value for the 500 ounces of what 500 for the tank to reach the 500 ounces of polluted water. So we have to use the original time to minus this one, times by the 2, and use the 800 to minus the whole component to find out the change of the initial volume. So after that, you can rearrange this Q1 rate function, and you can find out that you can find out the general equation for this one, for the Q1 function, and you rearrange that. You can rearrange them, and you find out that there is one Rx which is 15. So we have to use the inhomogeneous equation formula to do so. As you can see, we can find 3 over 800 as the F and 15 for the Rx. And we can find the Rx, we can find the IF by using the formula as is not stated in here, but I will explain for you guys to hear. IF has a formula of E to the power of integral of fx. So fx has the number of 3 over 800. So if you put in the fx into the formula of if, you'll find out that if is the e to the power of 3 over 800 t. So after that, you put the if into a formula again. The formula is u. The formula is u I multiplied by if equals to the integral of rx times the if dt. So after that, you'll find out that the c will have a value of negative 3998. After that, this equation will be formed. So that's all for my part.
Okay, hi. Let me start with what Liana feels now. So when we substitute Q1 T equals to 500 inside the equation, we get 4000 minus 3998 to the exponent of negative 3T over 800 equals to 500. So the Tm we will get is 35.4750 hours. Next. So let me explain about the Q2 for the case study 2. So the Q2 prime of time is negative 2Q2 time divided by 400 minus T minus Tm. Tm just now Dian told us that the time taken for the water to get polluted. Okay, and Q2 the Tm is 500. So when we substitute the just now the Tm we get is 35.475 hours, right? So we substitute into the Q2. So when we substitute into the Q2, we get it Q2 negative 2Q2 time divided by 435.475 negative T. So the range of time for Q2 is between 35.475 and 435.475. For the y over dt, you will get negative 2y divided by 435.475 minus t. So let's put q2 over q2t equals to y. Just substitute y into the q2 and you can get the equation.
Okay, after we get the equation for Q2, we integrate it using IF to find the value of Q2. And by inputting the value of at t equal to 35.475 hours, we will get that the mass of the polluter will be 500 ounce. Okay, from there we can find that the final equation is Q2T equal to 435.476 minus T to the power of 2 divided by 320. That's the final equation. So at the end, our final answer is Qt equal to 4000 minus 3998 times e to the power of negative 3t over 800 is between 0 to the time of 0 hour to 35.77 hours, and the other equation is between 35.475 hours to 435.4758 hours. The value of the value of qt is 435.476 minus t or the power of 2 divided by 220. The value of 435.4758 we can find by doing the graph in the following slide. Okay, so from the graph here, this is the first graph of the one with the 4000 minus 300 3998e, and then it's a graph by this the function drawn if you function drawn from this is a function drawn from the 435.476 minus t to the power of 2 divided by 320. So on the graph, we notice that when it continues to decrease, it decrease to 0. And we found that the value is 435.4758. So the maximum pollution is 500 ounces at 35.475 per hour, and the minimum pollution is 0 ounce at 535.475 per hour. That's the end of our presentation. Thank you, Dr. Shakina, for listening. That's it. Okay.